Welcome to the last part of tutorial Coughin Dance, in which we will use our transformers and build music. For those of you who do not have an external synthesizer, I've added an argument xMidi, and if you set it to 1, the external synthesizer will be used. If you set it to 0, the internal synthesizer in supercollider will be used. However, I did not make any nice instruments, so it's just using the default instrument as just to reduce the amount of code and the amount of complexity. But if you, as a hobby project or whatever, come up with some nice instruments to go with this, by all means let me know and we can extend the code. And I will also store all the variations that we built into an event. But I will not bother using the save registration method there, because I will store it under keys that I'm absolutely certain are do not have a predefined meaning. I'm here also declaring a tempo clock, which sets the tempo to 26 beats per minute. I'm setting up some volume for the left and right channel. If xMidi equals 1, that means we will be using an external synthesizer. Then you have to initialize your MIDI client and connect to your MIDI synth or keyboard, as we discussed also at length in the previous tutorial on Project FreeJazz. So here's the transcription of the Coughin Dance, one that you would recognize as closer to the original. And here is the modified one that I used to create the video to avoid copyright issues. As a first step, I'm extracting from the Panola specification all the MIDI note numbers and the duration numbers, and I do so both for the left hand side, which is the bass line, and for the right hand side, which is the melody. And I'm building here two lists of notes and durations, because that's the format that will be used by our transformers, as discussed in the previous part of the tutorial. So first I register all my transformers, which we discussed in the previous part of the tutorial. I will skip that now. And here we finally start to make some patterns. I've also added a kick. When using the external synthesizer, I'm sending a MIDI note 41 with a duration of 1/4 note. So 1 beat, this means. And I just make it an infinitely repeating pattern. I'm not even bothering calculating how many notes will play, because I cannot even know in advance. It would be difficult to calculate, and we will use a different trick to make sure that the kick stops when the rest stops. So we just let it play forever. If you use the internal synthesizer, I did not bother making any kick drum sound. So I've just replaced it with an infinite stream of rests. But if someone makes a nice kick sound, we can of course use it here. Instead of using instrument default, then you would here use instrument, for example, kick, where kick is the name of the synth def that generates the kick sound. Let's start to build our variations. We will be storing them in an event again, as we did in the previous part of the tutorial. And my first variation is just the left hand side and the right hand side playing in parallel. P-par is a pattern that plays a list of patterns in parallel, so at the same time. That means this is just the original variation without any calculations. And then I just at random, more or less, I started combining transformers. For example, I made a variation 2 where I kept the bass, but the right hand side I transformed with the spray transformer. And the result of this spray transformation I passed to the asPattern function, so that we have a fully fledged pattern that we can play. Then I made a third variation, and here I go a bit further. I still keep the normal bass line, but I play two versions of the right hand side transformed. First one is just the right hand side with an interpolate transformer, And then at the same time, simultaneous to that, we play the right hand side interpolated and retrograde all, so both the notes and the durations are reversed. And by some happy coincidence, which I embraced, it sounds together quite well. And I kept going like that. We made our transformers so that we can easily combine them together, and we will use that, of course. So here in the fourth variation, I used a spray transformation on the left hand side, so on L. So that means that we now transform the bass line. I also kept the original bass line because it's very... Having a bass line, a clear bass line, helps in keeping the structure of the piece clear. But it doesn't prevent us from at the same time also playing a transformed bass line. So here, for example, is a fifth transformation. I did not really think about all of these in a lot of detail. I just really tried some stuff and listened what sounded good to me. For example, here I make an inversion around the note A flat 5. And why do I do it around this note? Well, I tried many notes and I heard that with this note it sounded well together with the original right hand side. So it was basically trial and error until it worked. Of course you can do some mathematical stuff to try and guess the best possible inversion that will give you the maximum amount of consonant intervals at the stable scale degrees and stuff like that. Maybe that's stuff for a different tutorial, but basically in practice I just did trial and error until it sounded good. And so I kept going, making all the transformations, sometimes transforming the left hand side, the bass line, sometimes transforming the right hand side, mixing them together. Here, for example, I have many versions. I have a very rich variation where both the left hand side appears twice and the right hand side appears 4 times. So we have here a retrograde playing together with an inversion, together with an invert retrograde, and together with the original right hand side. This would be something that perhaps makes Bach proud, because that's the kind of stuff that he also did in his music, where he really played all kinds of themes together and transformed versions of the themes also at the same time. And luckily for me, the theme was quite simple, and it just works if you play it backwards or inverted and retrograded. It just all works very well together. But of course it's up to you. So here this variation 8 is the very crazy one that you heard in the very first video in this series. So it uses a lot of ARP on spray of retrograde, so that's quite a complex combination of stuff. And then ARP of retrograde of interpolate, and in this ARP I even specify non-octaves, so really complex transformations. And if you saw this as music notation, you would not even recognize anymore that it is related to the original pattern, to the original melody. But as you can see clearly, it's really just some mathematical formulas that we apply. So what I did then was to listen to all of the variations and to order them such that the music contains a kind of build-up in complexity. So we start with variation 1, which is the original theme, in fact. Then we go to variation 4, and variation 4 sounds a bit more complex. So this has the spray on the bass line, and it has the original melody together with the inverted, interpolated melody. And so on. So I just scheduled all my variations over one after the other with a P-seek, which we discussed at length in the free jazz tutorial. As you can see, I'm using here a kind of pattern that I never discussed before. It's called P-spawner. And what it does is it allows you to start and stop patterns in parallel. So in that sense, well, also not only in parallel, but also in sequentially. It's quite a powerful scheduler of patterns. A different way than what we did in the previous tutorial where we used the timeline class. And one of the nice things it has is it takes this argument sp, which stands for spawner, and on this sp you can call suspend all. And when you do that, the complete p spawner will stop. And that's the trick I mentioned that will make sure that the kick will stop if all the variations are done playing. So I here have the kick, which runs in parallel with all the variations. But once the variations are done playing, we then evaluate the p-func, which we discussed also in the project FreeJazz. And p-func will evaluate sp.suspend all. And the result of that is that not only this part of the p-spawner stops, but also this part is forced to stop. If you use a normal p-par, then the p-par keeps on playing as long as one of the substreams keeps generating events. So because kick is an infinite number of kicks, the p-par would never end. And with the p-spawner and the suspend all, we can make sure that the kick is forced to end as soon as this stream is done playing. And then the final thing is that, just as in the project FreeJazz, I define my command period class. I make sure that when you press command period or control period on your keyboard, which is the normal way to stop supercollider from generating any sound, you may have just sent a note onto your external synthesizer, for example, and then the note can hang because no note off is sent anymore and supercollider has stopped generating MIDI information. So when I will press control period or command period, this do once will kick in and it will stop the player if it was still playing, and it will also send a notes off command on every MIDI channel so that there are no hanging notes on your external synthesizer if you press command period in the middle of the piece. Well, that concludes everything you needed to know to recreate what I created before. I hope you enjoyed it. I hope you learned something. If some things are not clear, please mention them in the comments. If you have suggestions for other topics, also be sure to mention them in the comments. I hope to see you again for some more algorithmic composition with supercollider the next time. Bye for now.